So a function is an operation. So again, on Monday, we talked about what's a type and what's some operations that can happen on a type. Okay, so again, with an int, you might have an operation being add. Okay, so a function allows us to define operations. Okay, and as you know, they can structure code and help us to do meaningful things with it. So functions have four things. They have a declaration, or a function prototype, and then they have a definition. The definition defines its name, return type, and then parameters that are accepted into the function. Okay? And you've got this distinction between formal and actual parameters. So the formal parameters, what the function actually takes in, are in the function's definition, so inside the .cpp file. Sorry, I've got that the wrong way. Formal parameters are like the int and the type, so the type specification, they go in the header file. The actual parameters are the names, so int I might be passed in to a function, and they go inside this .cpp file, so they go in the definition. So again, we've got this distinction between a declaration and definition, even for functions. And so what do you have to do? You've got to, this should be basic, should just be revision. A function has to have a return type, and if a function isn't going to return anything, it returns the type void. Void is a type. Okay? Functions cannot return arrays, and they cannot return other functions. Having said that, if you know a bit about programming, you can have a return statement that returns a call to a different function that calls that other function before it returns, and then the value gets copied back down. A function can also have an empty parameter list, okay, which means it's implicitly void. Okay, there's nothing passed into that function. Okay, this should all be revision at this point. And then you've got your basic functions that look a bit like this on the left-hand side. So, call by value. And everyone should have seen this again first year. We have a function called swap. Takes in two ints, copies one of the ints to a temporary file, or to a temporary variable, sorry, and swaps them around. Okay? So this is called by value. Inside main, the values of I and j are copied into swap. Okay? Now, as hopefully everyone notices, there's a big problem with this code. What's the problem with it? Doesn't do anything. Yes, it doesn't do anything because the values have been copied. So you want this thing to swap, and it doesn't work. So how do we fix this up? Well, yeah, we'll get to that. How would you fix this up as the C? Use pointers. Okay. So you use pointers. So suddenly you've got these stars going everywhere. And down here you pass the addresses in. This is still call by value at this point, okay? Because what's happening is values are still being copied in to now for pointer to x and the pointer to y, okay? The values are being copied in a memory address, okay? That's still a copy, it's still call by value, okay? Call by reference is these ampersands sitting here. This works in a very similar way to the call by value of pointers, okay? But you're not dealing with pointers anymore. You're dealing with references, okay? And that means that the ampersand for reference goes up here in the function parameter list. And down here in swap, we don't have the address of memory anymore. We just say swap ij, okay? So call by reference is very, very powerful. It means we're not dealing with pointers, okay? Or we're letting the compiler deal with the pointers themselves, okay? So it's important to understand the distinction between this. You're going to end up using call by reference an awful lot, okay? But you need to know the difference between call by value and call by reference, okay? And again, there's these slides have been set up whereabouts there's codes in here, so call by value, .cpp, call by reference.cpp, and the pointer one. I'm not going to go into them because they should be reasonably clear. Okay. Okay. And so when you're deciding which one of these things to use in terms of call by value or call by reference, you need to consider when calling by value is a good idea or not a good idea. It's not a good idea to call by value if a function changes the value of an argument. So that was what's happening with our swap function. Swap was changing the arguments. You shouldn't call by value when you've got a large object. Okay? You shouldn't call by value and pass through a huge 100 million item array. That'd be very slow because you're doing all this memory copying. Okay? And we'll come back to this in a couple of weeks' time, but you shouldn't call by value when the object can't be copied. Okay, so there's ways in which we can define when something can be copied and can't be copied. You shouldn't call by value if the object cannot be copied, because call by value copies the object. Okay? And so like we've just shown you on the slides, there's 3 different ways of being able to get around this, or there's 3 ways in which you can do call by value and call by reference. It's the first year style, which would have just used int I and j. There's then the C style with pointers, and then C++ style with references. And you should use references where possible. Now, are we completely clear on references at this point? Because this is where it gets a little bit tricky. Okay, everyone clear on references? Okay, so we're now going to start talking a lot about what's called L values and what's called R values. Okay? L values are what's on the left-hand side, and R values are what's on the right-hand side. So if we come back to the code up on this right-hand screen here, when we say left-hand and right-hand side, we're normally talking about the equals operator, but not always. Okay? An L value you can consider as being a memory address, and an R value is what you can consider being at a particular location in memory. Okay, so we've got an example on the screen back on the left-hand side up here of int I. Okay. For I refers to a memory address 200. Okay, and equals 5 returns as the R value, as the object's contents. Okay. And so when we say in the second line here, I is equal to I plus 1, we're saying add the R value 5, so not 200, add the R value 5 and 1, and store that result, which is 6, into the L value, memory address 200. Okay? Now this also applies to containers, and we'll get to containers in a couple of weeks' time, but we can have a thing called a vector, and a vector can store ints. Basically, you can think of it as being a linked list for now. Okay? And so the R value is what's stored inside the vector, and the L value is, you can think of as being the address of the vector. Okay? Now, R values, so the actual locations of things, so the actual values of things, can only be on the right-hand side. L values can be on either the left-hand side or the right-hand side. What that means is I can say I is equal to 1, okay, I being the L value and 1 being the R value. I can also say J is equal to I plus 1, and see that I, which was previously an L value, is still an L value, but it's appearing on the right-hand side. Okay? But I can't say 1 is equal to I, because the 1 is an R value, not an L value. Okay? So it's going to take some time to wrap your head around, okay? But you've got these L values and you've got these R values. Okay, so now coming back to call by value and call by reference. Call by value uses R values, okay? It means that actual data gets copied, okay? And it means that it can't then modify the base of whereabouts it was, okay? Because the R value got copied. So in our situation, actually I'm going to bring it up now. In our code, let's take a look at it, call by value. When we say swap ij on line 13 here, okay? When we say swap ij on line 13 here, what we are saying, because this swap method is called by value, is copy the value, the R value of I and the R value of J across into the swap function. Okay? And that's why we can't modify it. When we're copying with pointers, we're still doing the same thing. We're now just using the address of I, which is also an R value, and copying that across. Okay? So we're still not at that point modifying the pointer, we're modifying the dereference to a pointer. Okay? With call by reference, the actual L value of the argument is passed. And that means we can modify both the L value and the R value of it. Okay? And it causes us to be able to eliminate the passing of large objects and these sort of problems. Okay? Now, Java and C are call by value only. Okay? Which is a little bit weird because if you've ever done a Java course with me, I keep on telling you Java doesn't have pointers, Java has references everywhere. That's true, but Java, even with its references, uses strictly call by value. Okay? C++, you've got the choice of being able to use call by value or call by reference. Okay? And you should understand the distinction. You should understand the distinction between L values and R values. So again, just for the sake of pushing this example further, here's this code again. X is 1, Y is 2 on entry. They get swapped inside this function called swap correctly, but outside of it they stay being 1 and 2. With pointers, remember our example from Monday, whereabouts we had the pointer and the pointee. So pointers are different. They've got both the type being the pointer and where they're pointing to, so they've got association between two different types. You have X pointing to 1, so that's the dereference, and J pointing to, so Y pointing to dereference there, so J. You swap that with the dereference, and then it works. Okay? And you can say that the dereference X is an alias of I, and the dereference Y is an alias of J. And that's why it works. And with call by reference, again, we have I and X are alias. They're the same thing. They didn't get copied at this point. Now I and X refer to exactly the same thing. Okay? J and Y refer to the same things, so when they get swapped, the actual memory gets swapped at that point. And you can also think of X and Y being aliases of I and J. You can also think of a reference as being a dereference pointer. I prefer you didn't think of it strictly that way because otherwise you'll still get confused. Okay? References are not pointers. Okay? They cannot be treated as pointers. Okay? But having said that, they're almost always implemented as pointers, but that's underneath in the compiling system. Okay? Now, still talking about functions. Functions, of course, return things. And they can return pointers or references. Okay? But make sure these aren't local objects. Okay? Because it can badly stuff up. We've got a function f here that returns a pointer to an int. We then create a local variable called int local, give it a value 5, and we return the address of local. This code will compile. And you can do something like this. Int pointer get, so pointer called get local is equal to f, get that local pointer. Okay? When you try to run this, of course, it's just 90% going to crash. Not always going to crash. It depends exactly how your computer's working. Okay? But what's happened is this 5 up here has gone out of scope. It's been destroyed. Okay? So don't do strange things like this. Okay? If you wanted to return a pointer to something at that point, and we'll get to this in a couple of weeks' time, you should be using dynamic memory. Okay? So this 5 here should have been created on the heap and not on the stack. Okay? We'll address that in a couple of weeks' time. Now, another thing you can do with functions in C++ is give it some default values. So say we've got a method here that returns a string, and the function is called RGB, and it takes in a short int R, a short int G, and a short int B. And these equals give it default values, which means that there's now a couple of different ways of being able to call this function. Okay? We can just call RGB with no parameters, and that defaults to the parameters set up in function prototype up there. We can call it with one parameter, and it overrides the first one, and the next two remain defaulted. We can call it with two, and again, the last one remains defaulted. We can call it with three. Okay, we can override all three of those parameters. That's missing from that slide. Okay, and that allows us to completely define our own values going in there. But we can't miss the second one. We can't do something about it. We give it the first one, not the second one, and give it the third one. Okay. So the default values are used at the end. They're used for trading parameters. Okay, so you've got to be very careful about how you order things. The same applies for when you're creating them to start with. You can't say int x equals to a default value, y doesn't, and z does. That won't work. So default values are trading. Okay. Hopefully most of this should be revision. You can overload functions. Okay. And so functions that are overloaded have the same name, they can have different return types, okay? And they're distinguished by differences in what they pass in, okay? So we've got a print here, 3 different versions of print, 3 different declarations and 3 different definitions of print. One takes in a double, one takes in a string, and one takes in a character, okay? And that allows us to do things like print 3.14, and the double version is called print hello world, and the string version is called print A, and the character version is called. Okay? Now, the compiler has to work out which one of these 3 functions you want to call at the right time. Okay? And so this is known as overloaded resolution. Okay? Now, it's up to you as a programmer to make these things straightforward. You should be clear on which you're trying to do, and you should understand how your program is working. Okay? So there's a 3-step process involved. Identifying which functions you've got, selecting the ones that could possibly be the correct one, and finding the best match. Okay? And if this doesn't work, then you can get a compile time error. Okay? But the thing you've got to be very careful of this is unexpected results may occur from type conversions, promotions, and so on. So what that means is if we go back a slide, we had print double, print string, and print char. Okay? And then we had the call being print 3.14. What happens if I said print 3? Which one of these 3 things would get called? So if I called print and gave it an int, which one of these 3 would get called? Probably not the char one. I hope it's not the char one. So hopefully it'll get promoted to a double, hopefully, but you're never quite sure. Okay, so you should be very careful about checking these things out, knowing which way things work. Okay. Here's an example. Okay, so we have here a declaration for G, a declaration for a void F that takes an int, a declaration for F that takes an int and an int, a declaration for F that takes a double and has a double, and the second double has a default type, default value, sorry. And so if we call F with 5.6, this last one gets called. Okay? Now that hopefully should be straightforward to figure out what's going on there, but what's available at the time that F5.6 is called, all 3 of them are visible in the scope. The ones that it could possibly be are the void int or the double-double. Okay? And the best match is the double-double. So it's gone 5.6 is a double, that's a double. I don't have that value, but it's defaulted. I'm going to call that function. Okay? So we talked about const on Monday as well. Top-level const, okay, remember there's top-level and bottom-level const. Top-level const has no effect on objects passed to functions. Okay. What it means, and if you have a method here called lookup, okay, it returns a record. If you try to declare a function that takes in a phone, p, and a second function that also takes in a const phone, okay, that's a redefinition of the same function and gets ignored and gets converted into a compiler error, okay, because you've tried to declare two different functions that actually take in the same thing, and it doesn't know what one to call, okay. But for low-level const, so we talked about const with references on Monday as well. Again, if you get confused about the stuff, go back and look at the second half of Monday's lecture, okay. We can have a reference to a phone and a reference to a const phone. And these work. Okay? The top one doesn't work. The bottom one, with call by reference, does work. Because the way in which you read for references, they'll right to left. So that's a reference to a phone. That's a reference to a const phone. Okay? So we have phone P1 down here, and phone P2 here, and that phone P2 is const, cannot be changed, it's constant. Lookup P1 calls this non-const version, and lookup P2 calls for reference to its const version. Okay? Go back, take a look at the slides from the later part of Monday to understand how the const works at the top level and at the bottom level. Okay? Now, a lot of the stuff I'm just going through, you'll have to practice yourself and write some of the stuff out and have a play with it and see what works and what doesn't work. Okay? Because just reading off lecture slides is too much to process. Okay? Are we clear up until this point? Yep. Cool. Okay. So, putting it all to one side for a minute, let's talk about inline functions. Okay. We often like to declare functions because they make our code easier to read. Okay. Now, you might want to declare a function that said min, and it takes an int n and an int m, and it returns minimum of the two. Okay? But every time you call a function, your code slows down a little bit because you have to put everything onto the stack. Okay, so the stack gets increased, and in this case, because this is called by value, what happens is int n and int m get copied. Okay, so you've got a little bit of performance up there. You don't have much, it's tiny compared to the speed of computers these days. Okay. But you've got this copy that does go on. So if you're doing this, again, 10 million times, it's going to be slow. And so by making something inline, it means we declare this thing as a function. But when it comes to compiling it, that code gets substituted straight into whereabouts the code was. So the whole function gets copied straight in and gets treated as if it was just part of your outer function. Okay? Now, inline functions are one of these weird things that should be defined inside header files. Okay, so I've just told you for the last 2 days that put declarations inside header files and definitions in C++ files. Can someone tell me why an inline function should be defined in a header file? Why might that be?
It contains the definition as well, so it needs to be copied in.
So?
It contains the definition as well, so it needs to be copied in to wherever it's used.
Yep.
Well, because it's not compiled in a separate unit. It's compiled inside the things that encoded.
Yeah, so both of those are pretty much bang on. So if we go back to the third-party situation, if we had an inline function in that third-party class, we cannot compile it into the .o file for third-party.o because we need to expand that at compile time into the user code.cpp file. Okay? So inline functions need to be in the header files because they get compiled straight in to wherever we call them. Okay? And so basically what we've just said there, they get expanded inline at the call. So if we have standard cout call min of I and j, so this is going to print out hopefully either I or j, whichever one is minimum. Okay? Because min is in line, that code just gets substituted straight into there. Yep.
Are they almost set the same as macros then?
Yeah, they could be the same as macros, but we do not use macros. Yeah. So you could almost think of these the same as macros in the sense of you're defining something and get substituted straight in at that point. Okay. Now, the big difference between this and a macro doesn't do any syntax checking at that point. Okay. So macro just gets substituted straight in, no syntax checking, so it can cause you big problems in your code if you're not careful. Inline functions still behave the same way in terms of the syntax checking and stuff like that, in terms of parsing. Okay. So much better to do it this way. Yeah. Do you have a hand?
Is there a preferred link to an inline function?
Sorry?
Or is there a preferred link?
Yes, and they're missing from the sides. Basically, it's anything that's shorter than 2 or 3 lines. So like that min one is a perfect example, okay? Because it's nice and short. You do not want to inline something that's absolutely massive and huge. Okay?
Like, yeah, okay.
Yeah. There is reasons for doing so. Not that I can think off the top of my head, but normally anything that's short you want to inline. Oh, one of the key reasons why you wouldn't want to inline a really big function is remember a couple of things that are going on. If you had a third-party library, okay, if you had a third-party library, what you end up doing is revealing a halt on a source code in your .h file if you inline it, because all of those things need to go at that point. What you're also doing is, because you're copying all that code in, if you're calling the same inline function from lots of different other places in your code, you're actually making your code bloat, because you're copying all that function definition multiple times into multiple places. So inline functions are good for small stuff. It just needs to be copied and just do one thing. If it's huge, standard alone is the same function.